Okay, good morning, good night, good afternoon, wherever you are in the world. Thank you very much for joining us here at Sunset Learning Institute for the UCSX 5th Generation Update Tech Talk. My name is John Gardner, and I'm going to be walking you through the brand new 5th generation hardware that Cisco just dropped here in May for their unified compute system. So let's just go ahead and jump right in then. So the first thing I want to do is a quick agenda. I'm going to run through an introduction talking about why we moved to this 5th gen. This 5th gen hardware and what are some of the advances. And then I'm going to get right into it. So the X Fabric module, which connects our compute nodes to our processing nodes, our X440P, which is one of the processing nodes. Then our GPU front mezzanines, which is fantastic. It's replacing all of the drives in the front with just a couple of drives and GPU support. And then our 5th generation Fabric update, which is our Fabric interconnects, our input output modules, and our VIC. So let's go ahead and get started, folks. So first thing I want to do is I want to mention that Cisco, a couple of years ago, started taking a look at their product portfolio. Cisco had the B200 M5 M6s out, the C220 M5s were out. We were getting ready to drop the M6s. What we were trying to do is we were trying to figure out, do we have a product portfolio with the B200 M5 M6s that can support the workloads that we're seeing coming in the future? So we took what we had, the B200 M5, and we pitted it up against hyperconverged infrastructures, big data, Splunk, and we realized that these blades, the B200 M5s, M6s, they lack the number of drives required. A lot of them, well, actually all the B200 M5, M6s only came with 2 drives, and they also lack GPU support. There was no GPUs. So we were realizing that these application workloads, we're going to have to go to a specialized server or some sort of rack mount, like a C series, right? So what we wanted to do was we wanted to start bringing this product portfolio together. We don't want to have a B and a C series. We want to have a compute series. And that's really, folks, what the X series is all about, is it's blurring the lines between what a blade server traditionally could support and what it can support today now with our X210C series. So a lot's changed with Cisco over the last 10 years. We've got hyper-converged infrastructure, big data, containerized systems like Kubernetes and Nutanix, tons of stuff going on in the world. One thing that we wanted to do was make sure that we stayed up to date and up with the times. So one of the things, for instance, I do want to mention here is right off the bat, the entire X series is already PCIe Generation 4 compatible. We're also looking into liquid cooling for our CPUs and GPUs. By the way, we're also cooling 2 times more with 30% less power. So another thing is we are achieving 200 gig networking for our compute nodes to the network. So these are a lot of things that we've been working on through the last 10 years. And what it's really dropped us down here into is the UCS-X series, folks. One of the things that I do want to note is this is the X9508 series chassis, and it is holding, looks like 7 X210C series servers. A lot of this stuff, you know, we can kind of skip, but a couple of things that I want to mention here is that inside that chassis, from server to server, just internally, we're looking at 1,600 gigs of aggregate network bandwidth. That is absolutely phenomenal. And right now, with the 5th gen update, we're also looking at 100 gig end-to-end from these servers out to the network. And the last thing here, something that we've never supported inside the blade servers is GPUs. Now we're looking at 24 GPUs per X9508 series chassis. So in one of these chassis, I can hold up to 24 GPUs. So let's take a look at how we're going to support those 24 GPUs. The way that we're going to do that now is we're replacing node or the node in slot 2, 4, 6, and 8 with what we now consider a processing node, an X440P. So you're going to have a compute node here with your standard CPU, memory, and hard drive. But then if you want extra stuff like GPU, you're going to start using whatever is in slot number 2. Again, that is called an X440P. We'll talk about that more in depth in a little bit. What it's really doing here, folks, is if you flip the chassis around, in the back, we have these two modules called the XFMs, the cross fabric modules. There are 9416, and what they're doing is they're connecting CPU 1 in slot 1 to GPU 1. And I actually, let me see here. I already have this drawn out. I know this probably looks bad, but let me explain a couple of things here. Those two modules down at the bottom, that's these two modules right here, the XFMs, right? So that's these two modules right here. And so when we look a little bit deeper, we have these port groups sitting on each one of our compute nodes that each connects to an XFM. And then in slot 2, they have port groups that are also connecting to those XFMs. And so when we look at it a little bit deeper, what we're seeing is CPU connectivity through this XFM to the next slot's GPU. So, if you zoomed in, you took an X-ray of what was going on inside the box electronically, that's what's going on. So over here again, we have a CPU on slot number 1, being able to use this XFM to talk to processor node number 2 to get GPU support. So that's, by the way, folks, that is really, from a compute standard, that was the major update. So keep in mind this XFM, like I said, it's connecting the even and odd pairs. So slot number 1 is going to be using slot number 2. It is replacing your lower fabric module pair. Right now, if you're working with a customer that already has UCS-X, they have 2 modules down there, but they're completely blank, right? There's nothing in there. There's just 3 fans on each one of the modules. So what's beautiful about that is that these are hot swappable. So when you do get the X9416, you just pop those 2 modules out, pop the modules in, and look at this. It can be hot swapped, connects to every single server with no configuration required. Absolutely 0 configuration required to get this XFM, and this is what it looks like, supported onto the chassis and inside your Intersight dashboard. So here you'll notice that it doesn't look like there's a lot of components. One thing that internally Cisco's we've talked about is that these are actually just kind of like wired PCI Express version 4 slots from slot 1 to slot 2. They're like hardwired. So there really isn't any need for like an ASIC or any sort of processing to be done here. So it's really reducing heat and dissipation, which is very, very cool. So with that said, what does it look like internally? So this is a better graphic than the one that I showed you. I was showing you that we had these mezzanine cards. We have CPUs connected to these mezzanine cards and these port groups that live on the fabric expansion modules and on the X fabric modules. So the thing about this is on all of your compute nodes, you have another mezzanine that connects you to that second slot. Now, currently right now, that is called your mezzanine 14825. All right, so the X4040P node itself is really, really exciting because here's the thing, folks, it holds a bunch of GPUs, right? If you've been working with UCS for any amount of time, you know that the B series never supported the utilization of GPUs. There just wasn't enough room, inside that B series to support GPUs in a standard implementation. So what we have now today, what I want to introduce you to is the X440 PCIe node. So I call it a processing node, but it is a PCIe Express node that imagine this is just a large daughter card now on your server, right? So anything on that card, this CPU and memory can utilize. So we've got 2 form factors here. We've got a riser A and a riser B. Now, riser A, this is our dual width. Long story short, those GPUs require two channels to the motherboard, so we call it a dual width GPU. We can fit 2 of those into the riser A, And if you're looking at what GPUs you can use, we can use the A14, A100, and the A60, excuse me, for the Riser A from NVIDIA, by the way. So that's your NVIDIA A100 T4 graphics or GPU card. If you look at Riser B, that's using a single lane. So we call that a single width. Now, with that being said, those are going to be supporting up to 4 T4 Tensor Core NVIDIA GPUs. These are super popular right now. The price point is there for the customers. It just depends on obviously the workload. I did have a slide for showing you where these best live, but I've only got an hour. Okay, so the next thing that I wanted to mention here was again, how do these two communicate? So we've got a compute node here with CPU 1 needing to offload. So what it does is it has an XFM connection to slot 2 hardwired directly up to GPU 1. Now, I don't want to beat that to death. That's how it's operating, right? So these XFMs, they're in the back, they're plugging in here and connecting slot 1 to slot 2, 3 to 4, 5 to 6, 7 to 8. Now, I wanted to show you what happened or what is not supported, right? So what will not work with each other? So if you have two compute nodes next to each other, it has to be compute processor to work. So a compute to compute, they're going to work individual of each other, right? So they're not sharing any resources whatsoever. So over here we can see we see that broken here because we technically consider this the compute node as like a transmit, whereas the processor node is like a receive. So if we get down to it electronically, but because they're both compute nodes, that's the easiest way to say it. Because they're both compute nodes, they're not gonna share resources. But again, if you have a compute node in the odd number slot and a processing node in the even number slot, that will work. Now, I do want to show you something over here. All the way over here on slot number 7 and 8, you'll notice that we've got 2 CPUs, right, in slot 7, but we also have 2 GPUs. This is a standard X210C with a GPU front mezzanine. By the way, I'm going to be talking about that in just a minute. I do have a slide on that, but it's a whole new front of this 210C, right? But what it is, what it gives us access to is 2 GPUs locally, right? But as long as we have another riser over here, like Riser B that supports 4 GPUs, this slot 7 compute node is supporting 6 GPUs. I don't know. I'm nerdy, so I think that's awesome. Now, what you do is you then multiply that 3 more times. That right there, folks, is how you'd be getting upwards of 24 GPUs per X95. One moment. Okay, and so yeah, folks, that's how you're going to get 24 GPUs in this X9508 series chassis. You just replicate that 3 more times, and you got 24 GPUs. Now, one thing that I did want to do was give you a block diagram, let you see what the Generation 4 PCI Express lanes look like. By the way, folks, these are PCI Express, roughly 1.8, 2 gig lanes. So you're seeing, for instance, 16 lanes from Riser A's slot 1 to the XFM. That's 32 gig. That's roughly 32 gig. You'll notice that everything's 32 gig. So if we go over here, right, on our Riser B, again, these are 16 slots. So you have 8 and 8, that's 16, right? So 32 again. So this is actually the Riser B that's supporting that Tensor T4 core GPU. And again, that one's pretty popular right now. Now, I did want to get to the front mezzanine. So if I go to the next slide here we go. So what we're doing is just a little background for anybody who hasn't sat the full course here. The front mezzanine here, this front card, you can also call it a shelf if you want to. This is what's been holding our 6 SATA SAS or NVMe drives. One of the largest, or one of the biggest jumps that we had here in the X series is moving to a much larger local storage capacity. So we did that by implementing this mezzanine. So this mezzanine can take up to 6 drives, SATA, SAS, or NVMe. And we actually got a couple of different riser cards for it, depending on the drives you're using. If you want GPU connectivity, for instance, with the NVIDIA T4, what we can do is we can pull that riser out. So you can pull out all of those drives, and then you can replace it with this GPU front mezzanine, this GPU T4 Mez. Excuse me. What it is, and it again, very, very simply put, it's a mezzanine card that goes right into the front here. This is going to give you 2 Intel NVMe drives and also 2 T4 GPUs. Now, this is super important for standard workloads. So what we're trying to do is show you that we have a hardware portfolio that can not only just handle standard, web applications, that kind of stuff. We wanted to show you that we could also do Hadoop, SAP HANA, SQL, right? Oracle. We could do all of that right here on this workstation. And actually, this workstation would be phenomenal for a VDI implementation, virtual desktop implementation, because it has the GPUs to accelerate the graphics. So we're creating a large product portfolio that hopefully can adjust for all of the application workloads out there today. Now, again, I did want to zoom in and show you what this looks like from the block diagram. So you'll notice that these are 8 and 8. So this is 16, right? 16 lanes. And then you have 4 more here. This is 8 more lanes. So that's giving you 24 lanes. So these are actually just hardwired directly, 24 lanes from your NVMe drives directly to the CPU, and then another 16 from your GPU to the front of the mezzanine card directly into the CPU. So that's giving you, about 48 gigs of direct access from the GPU and the hard drives directly to the CPU. Very, very cool stuff. And then my personal favorite here is the 5th generation fabric update. So we got actually a lot of stuff in here to talk about. The first thing here is on the right-hand side, when we talk about the fabric, if you're not super familiar with a fabric, what it is think of it like a VLAN or just another network in your environment, but based on function, right? So for instance, I have a compute fabric. That's where all my UCS-X servers live. I have a network fabric. That's where all my Nexus routing and switching lives. And then I have a storage fabric, which that's where all my storage arrays and SAN switches live. Again, if you're not familiar with, if this is your first time here, a fabric interconnect is what's bringing those all together. To get that to work with UCS-X, you're going to need an intelligent fabric module. This lives in the back of your chassis. This is how you connect these interfaces. This is how you connect the servers to the rest of the network. Now on those servers, they have these VIC 15000 series, the VIC 231 that connects into the back of this intelligent fabric module. And that's, so these are the interface cards that the X210C is using to get out to the network, okay? So what we've done is we've upgraded all 3 of those fabric components, something that the compute is using to get out to the network. So with that being said, the first thing we want to talk about is the 6536 fabric interconnect. So the 6536 is our first, 5th generation fabric interconnect. We might have a couple more come out. We'll see. The beauty about this is it's 36 100 gig ports in a 1RU form factor. Now, what that means for you folks is that you support 32 ports of 1, 10, 25, 40, and 100 gig. absolutely phenomenal. But the last 4 ports, 33, 34, 35, 36, those are actually unified ports. Now, this is really neat. When the ports ship to you, they're Ethernet ports, 100 gig Ethernet ports. But what you can do is you can flip them into a fiber channel mode. That's what a unified port is. It allows you to turn off the Ethernet transceiver and turn on a fiber channel transceiver. That's right, folks. If you're not familiar with unified ports, I just made that Ethernet port a fiber channel port, right? And we support all the way up to 32 gig fiber channel. And actually, we do have a 128 gig transceiver right now with a breakout cable that does support 32 gig breakout interfaces. So this is just a very versatile device. Another thing to note here is that we support the connectivity down to the chassis with the 9108 100 gig or 25 gig intelligent fabric module. And just real quick here, let me draw something out here real quick for you folks. Okay, I'll clean this up here. So one thing that I did want to mention here is we're talking about the 6536s. These are our fabric interconnects here, right? So we're going to say that this is fabric interconnect A, and this is fabric interconnect B. Okay, I just wanted to make sure that we were all on the same page. This is my X90, oh, well, here we go, a 9508 chassis, and here's my server. On the back of those servers, in the back of this chassis, you had those 2 modules that went across on the top and the 2 modules that went across on the bottom. We already found out that these bottom ones are used for CPU to GPU connectivity. These top ones, they're actually the connectivity to your fabric interconnects. So the compute node uses 2 links to get to the fabric interconnects using these intelligent fabric modules. If you're familiar with UCS in the past, excuse me, these are your input output modules. That's there's not much else to say, right? If you've done UCS in the past, you know what an input output module is, and that's all this is. So what this is doing for us though, folks, is it's allowing us to connect to that XFM with 100 gig or 25 gig. So what that means for us is that we could upgrade our fabric interconnects right now and still support the current implementation, that 25 gig implementation that's out there today, right? Another thing is, okay, John, I've got an old 5108 series chassis, right? The old school Project California. Can we plug it in? You absolutely can, as long as you are running a 4th gen input output module like the 2408. Or you could also connect to our super popular 93180 fabric extender. And then internally, the VICs that are supported, we are still supporting the old school VIC 440, VIC 480, 1440, 1480. I know how to math. And we are still supporting the 14425 and 14825, and all the way into the brand new series, which is our 15231. By the way, when it comes to what compute series, we're supporting pretty much anything with an M6. So that could be your M6 210C, which is your X series server. It could be a B200 M5 or M6, or it could be a C series, but please keep in mind that that is a fabric interconnect attached C series. That's not a standalone. So this has to be connected to the fabric interconnect either directly with single or direct connect, or it has to be connected to an FEX 93180, then into the 6454. So with that being said, one of the things that's super important is getting off of the UCS manager and getting onto Intersight, the dashboard. To be able to do that, folks, you are going to have to upgrade the 6536 to the infrastructure bundle 4.2.2. Then you're going to run, then you're going to run through the setup script and it's going to ask you, would you like to be in UCS managed mode or Intersight managed mode? You're going to select Intersight managed mode. Now, with that being said, I have had partners and customers ask about what about the third gen stuff. I've been impartial to it mainly because, you know, we should probably be on, you know, generation 4 stuff. But we do want to mention that we do have post first customer shipment support for the generation 3 stuff, like your VIC 1380s. And also if you're running the 2304, so like a UCS Mini. But that you'd actually have to talk more to support on that one. So I would just upgrade to the 4th gen, but you know, that's just me. Now, if we look at the capabilities of the 6536, the first thing again is that it's a 36 port switch supporting all 100 gig. But keep in mind that I do actually have 2 more interfaces over here, port 9 and port 10. These actually, they downgrade support. So if you need something with 1 gig support, port 9 and 10, and only port 9 and 10 can be downgraded to 1 gig. So it does have backwards compatibility to 1 gig. Otherwise, you're probably looking at, excuse me, you're probably looking at 40 and 100 gig across the board. We are supporting QSA and the QSA28 adapters. By the way, if you don't know what those are, let me see. It's I think it's right here. I do have a slide on you know, support here, so I can paste that into the chat window. But you can look at the different transceivers and what a QSA is, and for instance, what are the 4x10, 4x25 breakout cables, and the by 8, by 16, and by 32 fiber channel breakout cables. These are actually really neat. These last 4 ports, those are the ones that I said can convert from Ethernet to fiber channel. So we're supporting 32 gig individual breakouts, which is very, very cool. Now, if you flip this thing around, you're actually going to see a large number of fans. There's actually 6 fans here. That's probably the most fans I've seen in a fabric interconnect in the full portfolio. We're also going to see 2 power supplies, 1 on each side, and then our classic L1, L2 ports with our management console. What I like is that Cisco, we drilled down into it so that you can see it, but I kind of like that new look. I don't know. I've been looking at the same console for so long. It's like, wow, that's a brand new, fresh look. But it's still the same stuff. It's still the L1, L2 ports that are connecting between the fabric interconnects. We're still using those for updating and synchronizing ARP and MAC databases for failover. But please keep in mind, the fabric interconnects, when you go into UCSX Intersight managed mode, please keep in mind that you're no longer using a management cluster. So the L1, L2 ports used to be used to synchronize the config. We're not doing that anymore. We're simply just, we just have a data plane at this point. The management is now going through this management port to the Intersight dashboard. So the L1, L2s don't need to do anything with the management anymore. So they're just basically failover and keep alive links at this point. We still have, we still have our good old fashioned console cable. And yes, you're still going to use that to plug in your console cable, power it on for the first time, and run through that initial setup script through that console port. After that, then you'll access everything through the management interface. Oh, and we, as always, we've got that local USB port. So if you want to do, you know, a localized update, you can you know, put an infrastructure bundle on a USB drive, pop it in there, and transfer it through the CLI if you want. Okay, here we go. All right, so I did want to make a comparison matrix here for the interface types, protocol supports, and port roles. And there's a lot of stuff here to talk about. The interface type and speed, I don't think we need to spend too much time on. I already mentioned everything supporting, you know, Ethernet, fiber channel is the last 4 ports, 1 gig is 9 and 10. But this is what I want to get to is the protocol support and port roles. The protocol support, folks, since all interfaces natively support Ethernet, they're all natively going to also support fiber channel over Ethernet. As just a quick heads up, internal to this system, we already have the fiber channel forwarder, which is a fiber channel transceiver, which is used to switch fiber channel traffic. Excuse me. That's already enabled on the Fabric Interconnect. So that means that natively we just support fiber channel over Ethernet across that board with no extra support. You don't have to do anything. It's already supporting FCOE. But again, those last 4 ports, 33, 34, 35, 36, those can be converted to fiber channel. Now, this is where I take a side step, and I want to step back for a second and do a do-si-do. And just really quick mention here that when you convert an Ethernet port to fiber channel, tradition states that you're always going to reboot the Fabric Interconnect. You always reboot when you convert an interface from Ethernet to fiber channel. We didn't reinvent the wheel. That hasn't changed. And we're going to hear the same thing here once we start talking about port roles. So with the port roles, you can plug a UCS-X 9508 or a 5108 into any of these ports at 25, 40, and 100 gig support. Any of these ports can be an uplink out to your network. Only the last 4 ports can be plugged into a SAN switch going to your storage area network. Now, all of this is in end host mode. If you're not familiar with that, it acts just like kind of like a proxy. It just forwards the traffic to the network and to the storage area network. But the last couple here, like for instance, the appliance port. What happens if you want to plug, let's say, an iSCSI storage array directly into the Fabric Interconnect? There's a problem. In end host mode, the Fabric Interconnect only learns MAC addresses on server ports in end host mode, right? It's a proxy, it doesn't have to learn everything, right? So if you plug in an iSCSI storage array into this Fabric Interconnect, it's not going to learn that port because it's an appliance port. So one of the things that I mentioned here is that you do have to flip the Fabric Interconnect into Ethernet switching mode. Now that's going to do a bunch of things, but mainly enable learning of MAC addresses across server, uplink, and appliance ports now. Some might ask, why would you do that, John? There are smaller implementations that today, you know, the Fabric Interconnect is acting like a multi-layer switch, right? It's a super small implementation, maybe 2 chassis, and you want to be able to get to storage really, really quick. Why not just have it directly attached, right? It's a cheap solution, it's a fast solution, and it's a Cisco validated design. It works. But again, there are some caveats to plugging this appliance port directly in. Same thing with the storage port, fiber channel storage port, all the way to the end here. Notice this says will be available post customer or first customer shipment. Yes, correct. But keep in mind here that again, if you plug a fiber channel storage array directly into the Fabric Interconnect, again, you're going to have to move this into fiber channel switching mode. You're going to have to pull it out of that proxy mode and make it a fiber channel switch, right? And again, there's a lot of stuff that goes with that. So just wanted to make sure that I mentioned here that updating the fiber channel ports does require a reboot, and plugging the appliance ports and storage ports, please keep in mind, you're most likely going to have to reboot because you have to switch it from end host mode to fiber channel or Ethernet switching mode. Excuse me. Now, there are a ton of transceivers that are available, and as promised here, let me get back here. I'm actually going to take these 2 links here real quick. I'm going to throw them in the chat window. So, you know, I don't have any pens or anything, or t-shirts or hats. So, we've got swag in the form of links. So these 2 links that I sent And let me send it to everyone just to make sure. These two links, they're for the different interface types and transceivers that are currently supported for your the 3536. So, sorry, way here. Okay. All right. So yeah, I don't have a lot of time to talk about that. So just wanted to show you the links. You can go ahead and click on those, and those are yours. So the next thing I want to talk about is the intelligent fabric module. So this has been around forever. This is what connects the servers internally to the physical cabling to the fabric interconnects. So these live on the back of your 5108 series chassis. Now, this is the second version of the intelligent fabric module that we came out with. The first one was an X9108 25G intelligent fabric module. This one is the 100 gig. The only difference, folks, obviously, we upgraded to 100 gig, 100 gig per port. This is supported with the 6536 fabric interconnect only. So if you try and plug this into a 6454, not going to work, right? And it's definitely not, I'm sure if you're out there in the network, you've seen the 6248s and the 6296s, can't plug them in there. Their ASICs are not fast enough to support the 100 gig connectivity. Internally on this side, connecting to the computes, we're supporting the connection again to the 14425, 14825, and our brand new VIC 231. Again, this is a full 100 gig KR channel to each one of these intelligent fabric modules. By the way, another thing to note here is that tradition has been that, yeah, we've got 8 external ports. By the way, they're still called fabric ports. And we have 32 internal ports. So our oversubscription ratio is still 4-to-1. So just to be clear, if you're going to use the 32 25 gig interfaces, you are going to have to create 4 VNICs inside of the configuration so that they can use, so they can bundle and use all of the available bandwidth. If you're using the 100 gig IFM and the 15231, you only have to create 1 to maximize the effective bandwidth, which is very cool. The rest of the stuff is pretty standard. We're supporting enhanced security with FPGA, with the secure boot, with UEFI shell or UEFI boot optimization turned on. We're also Act 2 anti-counterfeit compliant. And again, this is going to connect to X nodes. So this is connecting again your X210C series out to your 6536. Well, a couple of important things also I should mention is that it is still hosting the chassis management controller. The chassis management controller looks outside these interfaces and figures out what fabric interconnect it's connected to for failover and redundancy. So it sees that I've got 2 connections, one to fabric A and one to fabric B, and it can figure out if either one goes offline and fail over to the other intelligent fabric module. So that's the chassis management controller. We also have a chassis management switch. That chassis management switch switches traffic from the external port right here to the internal port connected to the compute node. That is called a chassis management switch. So those are both still held here on the intelligent fabric module. And then the last thing here is you do have to be in Intersight Manage Mode version 4.2.2. Again, as a side step, you just download the 4.2.2 UCS infrastructure bundle and you install it. That's it. It's just like when you install the 3.2 or the 2.4. Excuse me, it's an infrastructure bundle. It's still the same thing that we're used to seeing from the past, right? But it just allows you to turn on Intersight Manage Mode. All right, now the 15231, holy smokes, there's a lot of things going on here. But the first thing that I do want to mention is that it is supported in the X series. There is some first customer shipment support required for the B series to support it. It doesn't. So the B200 M5 M60s do not support these right off the bat. You are going to have to talk to TAC to get those going. And it's actually them having to go in and extract a compatibility catalog piece and insert that manually so that it supports the UCS manager supports the 15231. So it's kind of a pain, but it's really just a small minor like software update there. Now on the 5th gen, we also support the C series. That's this one right here. That's the 15,000 series for QSA 28 cabled interface. So that's bringing this support all the way up to 100 gig end to end. So each one of these interfaces is 100 gig. This is giving you 100 gig. So it's still a CNA card. It's still a converged network adapter, which means that we can create 256 interfaces on this thing. And actually, by the way, not that it's any consolation, but we actually can build 512 interfaces now on this one. We didn't put it in the slideshow just because we weren't sure if anybody cared. But traditionally, we could support 256 interfaces. We're now supporting 512 fiber channel or Ethernet interfaces. So your VHBAs or your VNICs. Everything's Gen 4, and there's a whole slew of supported cool features. Not going to go over all of them, but I do want to go over just real quick these two features, RSS version 2 and VXLAN. Receive side scaling, what it does is it offloads the processing of layer 3 and layer 4 traffic onto this card, which is very cool. Why? Because now the central processing unit isn't doing that, right? So more CPU for you, right? And more offloading on these cards. So we're still supporting receive side scaling, and that's in version 2, but we're also now supporting the offloading of NVGRE and VXLAN inside of like your ACI fabric, for instance. We're supporting offloading of that layer 2 encapsulation onto these cards too. So long story short, layer 1, layer 2, layer 3, and layer 4 processing is all now being done on this 15231 card. That is phenomenal, right? When I was growing up, the central processing unit processed like layer 3 and above. Now it's only doing 5, 6, and 7. That's insane. So very, very cool stuff there. Don't have time to talk about all of the different features there. I wish I did. Real quick, just have a couple more slides here. What I wanted to do was show the support matrix. So if you're moving from the old 6454 environment with the 25 gig IFMs and the 14425 and 825 VIX, what does it look like from a bandwidth perspective? And what equipment are we going to be using? Now, down here, this says C matching topology on the following slide. Well, the conversion, unfortunately, didn't go real smooth here. These 4 network types are actually right here. So what I wanted to do was actually just jump right in. So what happens if you want full 100 gig end-to-end network connectivity? What we're looking at doing is you're going to have to update your intelligent fabric module to the 100 gig IFM, and then you're going to update your 15231 to the 100 gig, to the 15231 MLOB. Note that this port group, this is not a 10 gig or 25 gig KR channel. This is a 100 gig KR channel, right? So pretty insane. This is what gives you full 100 gig per IFM through the network. That's that dedicated 100 gig. Now, with that being said, I can also get to 100 gig with our standard VIC adapter, like a 14425. But the important piece that I want to mention here is that this could be the 15231, the new one, and it will negotiate that, oh, it looks like you're running 25 gig KR channels. I'll run 25 gig KR channels instead of the 100 gig. Point being, it's backwards compatible. So it's backwards, the 15231 is backwards compatible with the 25 gig IFM. This is what we have today, right now. If you're just running the 4th gen, you have a 14425 and a 14825, both providing 4 KR channels. So that's 100 gig per IFM. So this is actually giving you 200 gigs of effective throughput through 2 separate cards. So you're going to see a little processing delay here, but otherwise, that's what we're looking at today. And one of the last things that I want to mention here is I wanted everybody to see where our PCI Gen 4 support is. Well, I can make that super easy. It's everywhere. If you're still running the 14425 and 14825, I do want to mention that the communication path between the 14425 and 825 to the motherboard, just from the card to the board, that is a Gen 3, 16 by lanes. If you're running the 15231, everything is Gen 4. And last but not least, a lot of people ask me, hey, John, there was a lot of stuff that we went through, a lot of hardware, what's supported with the new stuff and the old stuff, right? So I went ahead, I created a slide here that shows you that we're supporting the C series over here on the right-hand side with a direct or single connect attached fabric interconnects, but you have to have them managed and connected to the fabric interconnects, and you can manage them through Intersight. Then you also support the C series with our FEX connection. So the 93180s, those are supported across the board. If we go here to your good old Project California 5108 series UCS chassis, the original, right? That's supporting, notice here, we're on the 4th gen. This is a 4th gen input output module. You should be on the 4th gen, the 1400 series inside of the B200 M5 M6s. That's one thing that they didn't really show. But yeah, you should be on the VIC 1440 or 1480 connecting to the 2408 input output module. And then we have those 25 gig connections up to the 6454. I'm sorry, the 6536. Then again, we have our 4th and 5th gen, our 4th gen hardware, which is originally what's out right now, 5th gen hardware with everything that we just talked about today. Your intelligent fabric module, your new 15231, and your X210C. So with that being said, please, whenever you get a chance, go to Sunset Learning Institute and go ahead and check out our Intersight deployment workshop. Right now, we're running a 20% off campaign, guaranteed to run August 2nd, August 3rd, promo code 20 UCSX. Also, keep in mind that we also have this thing called Next On Demand. Right now, we have all access membership for the next 365 days. That's going to include over 2,900 videos from us, the instructors, tech talk webinars from fantastic trainers with live and recorded sessions, discussion chat boards, and short stories, short study videos, such as blogs, articles, and quizzes to make learning much more fun. That's going to be $9.95 with code NEXT1K. And with that being said, I forgot to put my end slide here. Thank you all very much for joining us for the UCSX 5th Gen update. My name again is John Gardner, and it has been an absolute pleasure to present to you today the 5th generation update. Thank you very much.
If you like this video, don't forget to subscribe and click on the notification icon to get notified whenever we upload new content.